Welcome back, class, to another edition of Mr. Fitzgerald's biology class. Today we are talking about properties of water and its vocabulary. So previously we have already done some experiments with water, kind of looking and visualizing these vocab words. Now we're going to add some context to them, see what they actually are called in a science classroom, and learn a few more that we weren't able to experiment on, but hopefully they can make some more sense to you as well. So let's think back to what we did with the lab experiments. Well, the aspects of that experiment were we watched a paperclip float, we put drops of water on a penny, and we dipped a paper towel in water, and we observed the changes throughout the experiment with each of these. Now, what observations did we make? Hopefully we noticed that with the paper clip, it kind of sank into the water a little bit, but it looked like the water made kind of a net holding that paper clip upright and keeping it above the water and keeping it afloat. And once we got to a certain point, we had too many paper clips and they would start to fall in because now the water could not support all that weight anymore. On the drops of the penny, hopefully we noticed that water was trying to stay together through that whole experience in a small bubble that kind of leaked outward, getting towards the edges of a penny, even holding on to those edges before it eventually got too big and too massive and started to spill and ooze out onto the table. And lastly, we dipped a paper towel in water to actually see kind of that absorbency of the paper towel, but noticing how the water would move up the paper towel, moving against gravity and actually find its way through the little grooves in the paper towel in order to progress upward. Now, how that all relates today is kind of the different properties of water. So this is stuff that you're going to definitely have to know to have a background of water before you can get into its properties. So water has both a positive and a negative end. Unlike some other chemicals, it actually has what are called poles because one end is negative and one end is positive. Now, which one is the positive end? That's going to be your hydrogens. So here, these little gray spots here on these Mickey Mouse looking molecules are your hydrogens, okay? And the negative charge, if these are positive at the hydrogens, the negative is going to be with the red, that's the oxygen up here. So you can imagine this negative pole up here, these positive poles down here, kind of giving a polar or a kind of two-sided look to it. Now, what this is kind of cool with is now that we have these poles, we have this negative up here by the oxygen and this positive down here by the hydrogen, is we can create these interactions. They're not actual chemical bonds, but more of interactions between water molecules. And we call those hydrogen bonds because they're so close to being chemically bonded, just they're not sharing their electrons. They're kind of just being attracted to the fact that one is positive and one is negative. So for instance, we have, just like this definition here is going to say, we have the positive end of one hydrogen here, so this is going to be a positive end, being attracted to this negative over here, so that negative and the positive wanting to come together, and that's what forms our hydrogen bond. And it makes water very sticky. It wants to kind of stay together. We noticed that through a couple of our experiments. So hopefully you're starting to kind of put those pieces together. Oh, water was kind of staying together, it was sticking, and that's because, again, we have a positive end with the hydrogen, we have a negative end with its oxygen, and as a result, water can kind of stick to other water molecules, okay? And those stickings are called hydrogen bonds. So hydrogen bonds kind of come together in a little bit of a specific way with water in that stickiness, and that word is represented by the word cohesion. When you see that prefix co, that C-O, think of like co-op in a video game. Co-op means together, you're playing with another person. And hesion means kind of like sticking. So cohesion means literally sticking together. So water wants to stick to itself because it's got that positive side from the hydrogen and the negative side of the oxygen. They kind of make little networks and nets together. Sometimes we refer to cohesion as surface tension, depending on if we're talking about the surface of the water or as like a droplet. So for instance, the paper clips on top of the water, the cohesion that we were seeing on letting them float was that surface tension, how the surface kind of held together and wouldn't let those paper clips fall. But on the drops of a penny, it was making more of a rounded dome, kind of sticking together to itself. So kind of think of two water molecules holding hands, in this case two droplets, but two water molecules kind of holding hands, wanting to stay together because they have that attractive force. Again, it all comes down to the fact that there's a positive on one side with the hydrogen and a negative on the other side with the oxygen. and it's going to interact with another molecule because of that. Let's say this hand is maybe that positive hydrogen here. It's going to be attracted to the negative oxygen on this hand, so it's across a molecule. It's called an intermolecular connection here, intervening between two molecules. All right, and this is what gives us our water droplets, as well as kind of that surface of the water that doesn't really want to let things fall through it. Why you can float on your back or belly. I'm not very good at it, but some other people can float on water pretty well. The paper clips were able to float. Even boats were able to float because they actually have that concave shape that pushes water down and allows it to push out and allows that surface tension, that cohesion of all those water molecules to hold these massive cruise ships on top of them. So all that's because water just wants to stick together. Now there is another way that water can interact with things, and that's again sticking with adhesion, but adds adhesion. So it's kind of sticking to a surface like tape, okay? So in this case, water is going to stick to some sort of surface. So you can kind of think of like droplets on a leaf, where water will kind of stay with those little droplets on a leaf and make these little kind of balls that just don't want to fall down. It's like they're fighting against gravity. And again, that's all because water is not just sticking to itself, but it'll also stick to other surfaces where it can have those relationships where something is negative or something is positive there, and can kind of get a temporary hold to it. So it's all kind of related to the same thing as cohesion, but the only difference with adhesion is it's sticking to another molecule or another surface. Okay? Now, one of our last things that we observed in our activities that we demonstrated was capillary action. And this is where water can get a little creepy. And what I mean by creepy is it kind of flows up tubes. We saw this with a paper towel dip. It'll actually move its way up against gravity and kind of progress up little small tubes. Also, this is why when you're in a restaurant and you're drinking out of a straw through your cup of water, you place that straw in there, you'll notice the water level is here, but the water level in the straw is slightly higher. And that's because water is sticking and adhering to the surface of the straw, but also sticking to itself where it's pulling itself up. And this is, again, how our paper towels work. They're just little tubes inside of our paper towels that are allowing water to flow up. Now, some other ones that you might have heard in the past, so let's kind of dive into those. Water is the universal solvent. Hopefully you've heard of that before, and hopefully you've heard of a solvent before. But a solvent is the liquid part of a solution. Right? A solution is when you mix two things together. Usually one's a liquid, sometimes one's a non-liquid. And the solvent will be more the liquidy part here. And this one, these are called solutes, the little things that are dissolved in the liquid. This could be table salt, maybe sugar, something that's easy. So solvents, what they do is they actually dissolve other substances. So this liquid broke these little things apart. Instead of being one big chunk that was put in, now they're all spread out. All right. Water does this with a lot of substances. Given enough time, water can almost dissolve anything, again, if given enough time. If you look at structures like the Grand Canyon, those giant cliffs that are made, was all from the Colorado River, literally over time, slowly carving it out. And breaking that rock down over time and actually making now this big ravine that we see. So again, water actually will get through a lot of materials, again, if it's given enough time, but there are some things that it mixes very well with. Some things that don't really dissolve in water, things that are waxy. If you take a candle and put it in water, it's not going to do much because that wax hates water. So it actually will push against it. Some stones will hold it up against water pretty well, like slate. The top of those lab tables in your science classrooms are usually slate or granite. Some of those rocks are very resistant to water, so they actually push against it. Okay? Another cool thing about water is not that it dissolves everything, but that it actually can get bigger when it freezes. Now, that's kind of a weird concept to think of because we usually think of water being all the same size. All the molecules are the same size, all the particles are the same size. So how did it get bigger when it freezes? And it all comes down to the shape and structure that water molecules have. They make these little kind of L shapes. And when water's in a liquid form, they're able to kind of slide past each other and kind of fit in together. They will actually combine in some space. Because they have that negative and positive reaction, and it's temporary. So if two negatives get next to each other like magnets, they can push apart for a moment, causing this one to kind of flow up, but the positives might pull it back in. When water's frozen though, the only way that it can maintain its structure is to make almost like a crystal. where these things are all in nice little perfect uniform squares where these L's come perfectly together. So that way a positive is only close to a negative and a negative is only close to a positive. Notice how far apart these two negative oxygens are from each other and how far apart these two positive hydrogens are. This is the maximum space they can be apart, and that's what makes them happy. Remember, just like two magnets, if you put opposite ends, they attract, but if you put the same ends together, they hate it, so they usually try to push away. And so water does this when it freezes. It tries to push away from itself, so it gives this idea of thermal expansion. Thermal, you should think of heat, and cooling something down is taking heat away, and it's expanding while it's cooling. So instead of being all clumped together like it is in a liquid form, it actually will spread itself out, so that way it can have as much space in between these two negatives and these two positives as possible to keep the molecules happy in the mixture. Now, why is this important in biology? It actually saves the life of a lot of organisms, and we use it even in Florida, which is kind of weird to think about. So what this will do is in like northern states where they have ponds, the top layer of the pond will actually freeze. When a pond or a lake freezes over, it's not all the way through. Otherwise, that would kill all the fish and all the plant life in there. That's not a really good thing. So in the winter months, the top layer freezes because the air is going to be so much cooler and pull away the heat energy, causing ice to form at the top. But as you go down, if you were to drill a hole in this, you could actually go down and find fish down towards the bottom. And they'll start hanging out down low during these winter months because it's a little bit warmer down. Conversely, during the summer months, the top of the water is a little bit warmer because it's getting more of that heat exposure, so it's going to be warmer on the top and cooler on the bottom. So it flip-flops in the winter because that layer of ice is not letting all that heat be pulled out. It's kind of forming a protective barrier that keeps the organisms alive in it as well. So ice actually expanding while it freezes is actually saving the lives of a lot of organisms. Now, as strange as it sounds, we'll actually use thermal expansion in Florida as well. And we use it specifically with our vegetables and our crops that we grow, like strawberries. Think about the Tampa area. Strawberries are a big thing out in Plant City. And sometimes we do get frost in Florida in the winter months. It does get cold or below freezing overnight. So what those farmers will actually do is they'll go out and they'll spray the strawberries with water. You might think, why would you ever do that? It's not going to necessarily save the strawberry, it's just going to get them wet and the water's going to freeze. That's exactly what they want to do. They want the outside of the strawberry, that water, to freeze while those temperatures dip down below freezing overnight. So that way in the next day, the ice that forms on the outside is what thaws out and melts away. If they don't do that, the strawberry itself will freeze overnight, and now we'll get that expansion inside the strawberries, ripping the cells apart, so when it thaws out the next day, it'll actually rot. So it's not a very productive thing for them. They want to make sure they have as many strawberries as possible, so it's very common during freeze warnings. Farmers will go out and spray their crops with water to make sure that we get that expansion of ice on the outside and thaw it out the next day to protect the plant. All right. Another cool thing about water is that it regulates temperature. So think about how coastal areas always seem to have more people that live at them, right? The Tampa area has a lot more people than necessarily the center of the state. Sometimes you get a little bit more people in the center of the state if there's water there. And the reason that they want to live next to water is it keeps your temperatures a lot more moderate, more calm. Look at Los Angeles, California, for instance. So on that graph, a red line at the top, that's actually showing you the average temperatures of the month in degrees Celsius. So it's 14 to 21 degrees Celsius. So it's usually kept around a nice, cool, mid to upper 60s to 70s, kind of very consistently. So that is very consistent because they get this nice flow off the Pacific Ocean of breeze. So the ocean water is keeping it nice and cool, kind of pushing in to the inland and keeping them at a nice moderate temperature. On the other hand, you see this graph here, it says of Kabul, Afghanistan, something that's landlocked in a desert kind of region that doesn't have any water. Notice how the temperatures go from -2 degrees Celsius on average. That's below freezing. Remember, water freezes at 0 degrees Celsius, all the way up to about 25 degrees Celsius as well. So there's a large temperature swing. That's like going from below 32 degrees Fahrenheit to above 75 degrees Fahrenheit as well. So big swing in temperatures, and that's because they don't have water around them to help cool or warm them up. So in the winter months, Los Angeles is staying nice and mild because the water is actually kind of giving some heat to the land that would be a little bit cooler. In the summer months, it's giving some of that cool air. It's taking some of the heat away from the land, so it keeps that temperature pretty consistent. Afghanistan, in this desert landlocked region, doesn't have that water, so nothing is keeping it consistent. It's based on what the land is experiencing overall. Now, for us in Florida, why we want to live by the coast is because, again, the temperatures will stay a lot nicer on the coastal areas. Now, I know Florida's hot no matter where you go, but there's a difference between coastal, being on the ocean hot, and being in the center of the state hot. If you've ever traveled to Disney in the middle of summer, you know that, because in this region up here in Orlando, there's not a lot of water in this immediate vicinity except for lakes. So it gets really just hot and humid. Whereas if you've ever been to Cocoa Beach or somewhere on the East Coast, it gets a nice sea breeze, or even Tampa, St. Pete area, we get this nice sea breeze and this offshore flow onto us. We actually can cool our temperatures off a lot better. In our winter months, we stay a little bit warmer on the coast, so you're less likely to see frost on the ground if you live on the coastal areas than if you lived on the inland spots as well. So why does water stick to this penny? Well, you can look at it in two different ways, depending on what aspect you want to focus on. You can focus on the penny sticking to the water, so that would be an adhesion response, where water is actually sticking to that surface of the penny and holding onto it tightly. Or you can think about it as water holding onto itself and trying to stick together. In the center of the penny has cohesion. So either way that you look at it, it's sticking to it, whether water's sticking to itself with cohesion or sticking to the surface of the penny with adhesion. So either response would actually be correct in this one. All right, now you're going to move on to defining some vocabulary words. I really want you to hopefully use what you've learned in here and challenge yourself, and this is important. Your definitions need to be 5 words or less. If you write more than 5 words to define that word, it is incorrect. Okay? And what I'm trying to get you to do is shorten everything down, put it in your own words that you would hopefully remember, so when a test or a quiz comes around, you're a lot more prepared. So again, complete the activity using 5 words or less. I hope you all have a great day. See you later.